Hi everyone, in today's lesson from Unit 3.2, Part 2, we're going to take a look at coordinate geometry proofs. In this lesson, we're going to use formulas for distance, midpoint, and slope to prove that a quadrilateral is a special type of quadrilateral. For example, I'm going to prove that, say, something is a parallelogram, a square, a rectangle, a rhombus, or maybe even a trapezoid. To do this, we need to remember some specific ways to prove that a quadrilateral is, say, a parallelogram or a rhombus or a rectangle. So we're going to review some specifics about our special quadrilaterals. Now, number one is just the definition of what a parallelogram is. Opposite sides of a parallelogram are parallel. Number two, opposite sides of a parallelogram are congruent. And number three, we have a typo. It says the diagonals of a parallelogram. We're going to cross out the word are, and we're going to fill in the blank with bisect each other. Again, the diagonals of a parallelogram bisect each other. Okay. And number four, one pair of opposite sides of a parallelogram are both congruent and parallel, using the symbols here. So this would be one way to prove that a quadrilateral is a parallelogram, as are 1, 2, and 3. Okay, you can use any of these to prove that a quadrilateral is a parallelogram. And number one, to prove that the opposite sides are parallel, you would use slope. Number two, to prove that opposite sides are congruent, you would use the distance formula. And number three, to prove that the diagonals bisect each other, you would use the midpoint formula. And number four, you would use both the slope and the distance formulas. Okay, next let's take a look at number five. It says a rectangle has 4 right angles. To prove that the rectangle has 4 right angles, you would want to prove that lines are perpendicular to each other. So you'd want to use slope. Okay, number 6, the blank of a rectangle are congruent, and we're going to fill that in with diagonals. And again, you would work with distance formula to prove that they have the same length. Number 7, you have to keep in mind number 7 for later. Consecutive sides of a rhombus are congruent. So if you prove that something's a parallelogram, you can then prove it's a rhombus if you prove that two consecutive sides are congruent to each other. Number 8, the diagonals of a rhombus are perpendicular. Let's just use the symbol for perpendicular. Number 9, for a square, the diagonals of a square are congruent, and they're also perpendicular. Okay, remember that a square has all the properties of a rectangle. So since the diagonals of a rectangle are congruent, the diagonals of a square are congruent. And a square also has all the properties of a rhombus. So since the diagonals of a rhombus are perpendicular, that also means the diagonals of a square are perpendicular. Number 10, a square has 4 right angles and 4 congruent sides. And finally, number 11, at least one pair of opposite sides of a trapezoid are parallel. So if you use the slope formula and you prove that one pair of opposite sides are parallel, then you've got a trapezoid. So in order for you to determine if the quadrilateral is a special quadrilateral, you'll need to be able to find the slopes of segments and determine if they are parallel or perpendicular. And number 2, find the lengths of sides and or diagonals of a quadrilateral. So we're going to be using the slope formula and also the distance formula. So let's take a look at our first example. In number 1, it says the vertices of quadrilateral ABCD are given. Graph ABCD in the coordinate plane below and prove that it's a parallelogram. So point A is at -2, -2. So go to the origin, left 2 and down 2. I'm going to put point A right there. Point B is at 0, 4. So it's right up here. Point C is at 6, 4. Sorry, point C is 6, 4. And point D is at 4, -2. Okay, so we want to prove that this is a parallelogram. So nothing more specific than a parallelogram. So we only need to use slope, right? And what we're going to try to do is prove that both pairs of opposite sides are parallel. So I want to define the slope of line segment BC and find the slope of line segment AD. Now, since we have these points graphed, you can just take a look at the graph and find the slope. Notice that they're both horizontal line segments, so the slope will be 0. But just to be sure, I'm going to plug my points in to the slope formula. So I would do 4 minus 4 for the change in the y values. And I would divide that by 6 minus 0. 4 minus 4 is 0 over 6, which is 0. Okay, for line segment AD, change colors here. I'm going to use these 2 points. We want to find the slope, so we do -2 minus -2 over 4 minus -2. And we end up with -2 plus 2, which is 0, over +6, which is also 0. All right, that's enough information for us to say that those two segments are parallel. Okay, but that's not enough information to prove that it's a parallelogram. We also need to find the slope of line segment AB. And we have to compare it to the slope of line segment DC. Okay, for the slope of line segment AB, so here this point and this point, let's do 4 minus a -2 divided by 0 minus a -2. This is going to turn into addition because we're subtracting a negative, so you have 6 over. This also turns into addition. 6 over 2 equals 3. Okay, finally, find the slope of line segment DC, so the last 2 points. And let's set it up as -2 minus 4 over 4 minus 6. Okay, -2 minus 4 is -6. 4 minus 6 is -2. And when you divide that out, we get +3. So again, we have the same slope. These two lines are opposite and parallel to each other. Both pairs of opposite sides are parallel, so we have a parallelogram. In our second example, it says we're given points A, B, C, and D to determine if the quadrilateral is a square, rectangle, rhombus, parallelogram, trapezoid, or none of the above. Okay, it's going to be helpful if you draw a sketch. You don't have to grab the graph paper. We can kind of estimate where these points are. So 3, 2 for point A would be about here. 3, 5 would be just above it. Now point C is all the way at 11, 2. And point D is at 11, 5. Now notice that the name was not given to us. It doesn't go in the order A, B, C, D. It goes A, B, D, C. Okay, so we can prove that this quadrilateral is a specific type of quadrilateral, namely a rectangle, by using slope only. So let's find the slope of line segment AB. So we would do the change in y, so 5 minus 2 divided by 3 minus 3. Okay, that gives us 3 over 0, which is undefined. And sorry about that, it's undefined, meaning that line segment AB is a vertical line. And we can tell that just based off of the x coordinates being the same. Let's check out DC and verify that its slope is also undefined. So for the slope of line segment DC, we're going to do 5 minus 2. We're going to divide it by 11 minus 11. 5 minus 2 is 3. And we're dividing it by 0. And again, that is undefined. So that confirms that these two line segments are parallel because they're both vertical lines. Next, find the slope of line segment BD. So for B to D, it's 5 minus 5 over 11 minus 3. 5 minus 5 is 0 over 8, which is 0. And then line segment AC. Find the slope, 2 minus 2 over 11 minus 3. 2 minus 2 is 0 over 8, which is 0. That means that BD is parallel to AC, and they're horizontal lines. Okay, now we proved that this is a parallelogram just by proving both pairs of opposite sides parallel. But we've also shown that this is a rectangle. So more specific than parallelogram, we can call it a rectangle. And that's because any horizontal line is going to be perpendicular to a vertical line. So indeed, this parallelogram has 4 right angles, so it is a rectangle. All right, good luck on your homework.